Okay, so now we know what a convergent series looks like and what a divergent series looks like. Let's start talking about the what actually happens when you add up the terms of a convergent or a divergent series. So the series or the sum of a divergent series is non-existent. It doesn't exist. Sometimes it'll add up to and get closer and closer and closer to positive infinity. Sometimes we get closer and closer to negative infinity. Sometimes it gets a little weird. We're not going to get into all those details. But the sum of a convergent series, we actually can add up an infinite number of terms. Let's go back and review the formula that we used for the sum of a geometric series. It was S sub n equals a sub 1 times 1 minus the ratio to the nth power over 1 minus the ratio. Now, in this case, it would be S sub infinity. You're adding up an infinite number of terms. So it would be a sub 1 times 1 minus r to the infinity over 1 minus r. Now, I'm going to deal with this guy right here. R to the infinity. That seems impossible. Well, let's do a side example here. Let's say we're dealing with an example. Let's see. R equals 1/2. Okay, so r to, or 1/2 to the first. Let's just start with that. 1/2 to the first, thinking about it as a decimal, 0.5. 1/2 to the second equals 0.25. Let me just jump and get a little larger. Let's do 1/2 to the sixth. 1/2 to the sixth, if you were to do that as a fraction, would be 1/64th, which is 0.015625. If you're to do an even bigger exponent, 1/2 to the 10th, I'm not going to bother writing that as an exponent, or sorry, as a fraction. If you write that and type that into a calculator, you end up with, it says 9.7 e negative 4. Now what that really means is it's 0.00097 and it keeps going forever and ever. That's really, really, really small. Now if you do, like, say 1/2 to the 100th, your calculator would just give you 0. Let me actually erase that equal sign because it's not exactly 0. It's just so painfully small that your calculator doesn't know how to handle it. So, as since r is a small fraction, as r gets closer and closer to infinity, we're just gonna say a sub 1 times 1 minus 0 over 1 minus r. Well, cleaning that up a little bit, we would have a sub 1 times 1 over 1 minus r. And we can clean that up a little bit more. We're just going to say, instead of saying s sub infinity, we're just going to say s equals, thinking about this, a sub 1 over 1 times the fraction 1 over 1 minus r would be a sub 1 over 1 minus r. It's kind of a weird concept that even though we're dealing with a huge number, literally an infinite number of terms being added together, the formula is actually simpler than if we were adding up a finite number of terms together. I want to take a look at what this would look like on this example. It says find the sum of the infinite geometric series if it exists. So the first thing we got to do is we got to figure out whether the infinite series is going to exist or not, or the sum is going to exist or not. What we need to do, we got to figure out what r is. We got to take one term divided by the previous. So I'm just going to take, well, the second term divided by the first. Now, we do need to pay attention to signs here. So I'm going to say it's negative 0.2 divided by 1, which is, well, negative 0.2. If you want to put that as a fraction, it's negative 1/5. If you want to check to make sure that is consistent with everything else, take another one. I'm going to do negative 0.08 divided by negative 0.04. So, sorry, 0.008. Negative 0.008 over positive 0.04. If you punch that into a calculator, you're still going to get negative 0.2 or negative 1/5. Now, plugging that into our formula that we had s equals a sub 1 over 1 minus our ratio. A sub 1, our first term. So we got s equals 1 over 1 minus our ratio, which is negative 1/5. cleaning that up a little bit, we got 1 over 1 minus negative 1/5. Remember, subtracting a negative is like adding the positive, so it's 1 plus 1/5, which we could describe as 6 over 5. 1 divided by 6 over 5 is the same as 5 over 6. So the infinite sum, S, equals 5 over 6. Now, I'm going to jump over to a calculator. I'm going to show you what that's actually going to look like, or kind of how you could represent that. Let me see if I can get out of here. All right. So let's just kind of start adding those terms together. So the first term we had was 1. Super exciting. The next term we had was minus 0.2. Then it'd be plus 0.04. Hold on a second. There was a typo here. Let me start that over. 1 minus 0.2 plus 0.04 minus 0.008. The next term would be plus, sorry, I'm getting ahead of myself, minus 0.008. It's also weird typing this on this computer as opposed to on a calculator. Plus 0.0016. The next term would be minus 0.00032. The next one would be plus 0.000064. The next would be minus 0.1234. Oh, no, one too many. 128. And we keep on going. Let's see. Plus 0.00000256. And you'll see it's getting closer and closer and closer. You see we're getting more and more 3s as we go along here. So it's like 0.833333333, and then 76. Let me just do one more. Let's see. Minus 0.1234512. And we just keep getting more and more zeros. Remember, we said the sum was supposed to be 5, 6. So let's see what 5, 6 looks like. 5 divided by 6 is 0.83333333333. The more we keep adding smaller and smaller terms here, we're getting a longer and longer decimal. It's technically getting bigger and bigger and bigger, but it's getting closer and closer and closer to this 0.833333333. It's kind of weird. We can add up an infinite number of things and end up with a finite answer. Let's try another one with example 3. So example 3, it says find the infinite sum find the sum of the infinite geometric series if it exists. So we got the summation notation starting off with the first term k equals 1 going up to infinity. So we're just going to keep on adding terms forever and ever and ever. Equals 1/2 raised to the k minus 1 power. So the formula again, S equals first term over 1 minus our ratio. Now our first term, we'd need to figure that out. A sub 1, we just got to plug in 1 for k. We have 1/2 raised to the 1 minus 1. Well, cleaning that up a little bit, we got 1/2 raised to the 0. Remember, anything raised to the 0 is always 1. Our first term is 1. Our r value, it's whatever is being raised to the exponent. It's the number that's being multiplied by over and over and over and over. It's 1/2. So we have S equals a sub 1 over 1 minus r. That gives us first term 1 over 1 minus our ratio of 1/2. Well, 1 minus 1/2 is 1/2. So we have 1 divided by 1/2. Putting that into perspective, that's 1 times 2 over 1, multiplying by the reciprocal of the denominator. So it ends up just being 2. In other words, taking a look at what this would look like if we were to find every term and add them up, it would be 1 plus, the next term would be 1/2, plus 1/4, plus 1/8, plus 1/16, plus 1 over 32, plus 1 over 64, plus it, and it keeps on going forever and ever and ever. Jumping back to the calculator again, let me show you what that looks like as we get closer and closer and closer. Let me see if I can do this on nice and smoothly. Let me clear all this out. So first term we had was 1 plus 1/2. I'm going to do these all as, 1 plus 1 divided by 2. So just kind of taking it a step at a time. So those are the first two terms add up, plus 1 divided by 4. Sorry, getting ahead of myself. Plus 1 divided by 4, plus 1 divided by 8, plus 1 divided by 16, plus 1 divided by 32. And I can keep going. Plus 1 divided by 64. Come on, 4. There we go. Plus 1 divided by 128. Plus 1, my mouse is there, sorry, divided by 256. You'll see it's getting closer and closer and closer to 2. Plus 1 divided by 512. Plus 1 divided by 1024. Plus 1 divided by 2048. Plus 1 divided by 4096. Folks, you can see it's getting closer and closer and closer to 2, but never quite getting there. So jumping back to the notes here. The sum of this infinite series is just 2. Crazy.